We're going to take a look this week at 3 sections, 7.2, 7.3, 7.4, okay, all on logs. Focus here is pretty much going to be on solving different kinds of equations. Not really anything graphical, sketching, drawing, just pretty much solving equations. So if we take a look at that equation, okay, 2 to the x equals 15. It's not that long of an equation. Okay, just 2 to what power gives you 15? Well, let me ask you something a little simpler. What would be the answer to that one?
4.
3. 2 to the third power would give you 8. How about the answer to that equation? 2. 4 to the second power would give you 16. What makes this one harder? How come it's the same kind of thing? It's just 2 to what power is 15? Why is it any harder than the other two?
Because it's not a direct number.
What do you mean
Like
direct
it's
number?
not a counting number there.
15 is a counting number.
No, I mean like the exponent's not going to be a counting number because 2 can't multiply evenly into 15.
Yeah, there's no, 15 is not a power of 2.
Yeah.
So if you try to raise 2 to a power, you can't get 15 with like integers or counting numbers, right? It's going to have to be, well, 2 cubed is too small, but 2 to the 4th power is too big. So the exponent is a decimal. And the way we would figure out what that decimal is, we would have to use a log. So that's basically what logarithms are used for. Anytime you have to solve an equation where the variable is in the exponent. Where does that happen? If you look at this equation, does anyone know what this is? Give you a hint. R stands for rate. Does anyone know what? And P stands for principal. Does anyone know what that is now? That equation tells you how much money you would have in a savings account. If you had a certain amount of money you put in on day 1 and you didn't touch it, you just leave that money in there for like 2 years at a certain interest rate. This would tell you the amount of money you would have at the end of a certain amount of time. So basically it tells you how much interest you make. If I said to you something like, tell me how long it would take if you put $500 in a bank account for you to have $600. If you never add to it, you never take away from it. But if the question was how long would it take, well, the problem with that is the t, which is the time, it's up in the exponent. It's a variable in the exponent. So you can't solve for how long it would take to do that unless you know how to do logarithms, because it's a variable in the exponent. Right, so there's various formulas that have variables in the exponents. And there's one that's really not super complicated, pretty real life kind of thing. It has to do with banking. We don't get into the banking a lot. That's actually section 7.5. It's a whole section on like interest rates and that kind of stuff. But if we had a 4-day week, we could have gotten to it, but we won't get to it. So all those expressions I just showed you, all of these, something to a power where the power is a variable, those are called exponential expressions. Actually, those even went one step further. These are exponential equations because they don't have equal signs. If you take something and you get rid of the equal sign and you just write like 2 to the x, that's an exponential expression. Let's see. Okay, exponential expression is anything that has a variable as an exponent. Okay, here's a couple more. By the end of the week, you'll be able to solve equations that have exponential expressions in them. And we call those exponential equations. So anytime you want to solve an exponential equation, especially if it's the kind of problem where it's like 2 to the x equals 15, where you can't figure it out in your head, it's not a nice answer, we're going to change it. Okay, the way we're going to change it is we're going to try to get rid of that variable. Well, we can't get rid of it, but we can move it somewhere else. If we can at least move it so that it's not an exponent, that makes it easier to deal with. And the way we move it is we're going to change from what we call an exponential expression to a logarithmic expression. Okay, so if you've used one of my calculators and you've seen this button right here, it says log. That's kind of what we're looking at this week, log. And then there's this other button below it, ln. We use both of those when we do logarithms. Does anybody know what ln stands for? All right, we'll go over that. We're going to talk about that a little bit later. So first thing I just want to show you is what a logarithmic equation looks like. That red line that's going horizontal, that kind of represents like the line on your paper. So when you write a logarithmic expression, the letters can change, but you have a letter, the equal sign, the word log, and then you have a number that's next to the log that's a little lower. Okay, if you were writing it on line paper, that letter would actually be like right under the line. And then you have another letter after it that's right on the line. There's no exponents there at all. Okay, sometimes people look at that and they say, oh, isn't the x an exponent because it's higher? No. The a is actually lower than everything else. An exponent would be up here like that. Now there's an exponent. So I'm going to talk about how you pronounce that, but I just want to make sure everybody knows how to actually write it down on paper first. All right, so there's a formula to change between something that's written as an exponential expression and something that's written as a log expression. And the formula doesn't really involve any kind of calculation. All it involves is looking at where stuff is and where it all moves to on the other side. It's just stuff moves around. There's no real math you have to do it. Okay, so let's start with an exponential expression, okay, on the left. So I have x equals a to the y. If this was a problem you were going to solve, some of those would have to be numbers, okay, like something like this. X equals a to the y. I filled in some of the numbers here. But that's just a generic one. No numbers in that exponential expression at all. Now, the y, what do we call that? Because that number is a little bit higher. What do you call when you write a number a little higher than other numbers? Yep.
Exponent.
That's your exponent. And it's an exponent on the, what do you call the thing that's right next to the exponent, but it's a little lower? Yeah, that's your base. What's nice about that term is when we write things as a logarithm, the thing that started as the base is still called the base when we rewrite it. So here's what it looks like when we rewrite it. This number, like if this was your line, if you had line paper, that number that's below the line right here, that's your base. That's called the base on the logarithm. So the base on your exponential becomes the base on your logarithm. Base, think bottom. It's on the bottom. It's lower.
Is that a negative y?
No, I think I had put in a dotted line and that didn't erase. Yeah. That's a bad place for a dash, though. All right, so that's the first thing. The base on your exponential becomes the base on your log. The other thing is you always want to remember, logs equal exponents. So if you can remember that, it's going to tell you where something else goes. Logarithms always equal exponents. So when you do a problem like this on your calculator, the log of 5, that number that you just got there, 0.6989, keeps going, that number is an exponent. What is it an exponent on? Well, I don't know the whole problem, but it's an exponent on something. Whatever the problem would have been that caused you to take the log of 5. Okay? So logarithms always equal exponents. That's why on the other side it says log equals, and look at the thing that's right there, the y. The y was the exponent. So the logarithm always equals the exponent. And then the last thing, that right there, that's the thing you're taking the log of. That's called the argument. And if you can remember it's called the argument, that's gonna help you out. Okay. Look on the left-hand side. Look at that equation. X equals a to the y. How many things are on the left-hand side?
1.
Just one. What's all by itself on the left-hand side in that?
X.
Just the x, right? Think about if you argue with people a lot, right? If you argue with people, you're going to annoy them. They're gonna just not want to be around you, and you're going to end up all by yourself. So that's how I remember that one. The argument ends up alone, all by itself on that side. All right, so really, if you can just remember where 2 out of 3 of them go, you don't even have to remember the third one, because there's only 3 spots. So, but that's how I remember it. Logarithms always equal exponents. And if you argue with somebody, you're going to end up alone. If you're arguing, you end up alone. And then the base stays as the base. All right, so how do you pronounce that thing that's on the left-hand side, right-hand side? So you would pronounce it y equals, that's the first part, log base a of x. Y equals log base a of x. So when you ask somebody to take a log, or when you pronounce a log to somebody, you have to pronounce 2 things. You have to tell them what the base is, and then what the argument is. That's a little different than if I said something like this. Sine of 10. If I want you to take the sine of 10, there's only one thing I have to tell you. I just have to tell you the argument. I want you to take the sine, and here's the argument, 10. So you just type it in. With logs, I can't just say take the log of 10. I got to tell you a little more. I got to say I want you to take the log of 10, but I want you to use a certain base to do it. And that means something. So we'll go over what that means. So y equals log base a of x. That's how you pronounce it. All right, so let's take a look at something that's in log form and see if we can change it to exponential. So what this is going to do is it's going to get rid of the word log. Okay? Sometimes we want to have log. So sometimes we want to change it to log. We're going to do that next, change to log. But for now, let's change it the other way, to an exponential. All right, first thing, I just want to read that. Can somebody just read what example 1a says? About Eric?
Y equals log to the third. I'm not really sure.
All right, so how, let's go back to look at how I said to pronounce it. So we read this, colon, y equals the log base a of x. Except you change a to whatever the number is in your problem, and you change x to whatever the number is. All right. So how about now?
Y equals log base of 3 to the x. I don't know.
So we want to read it exactly. Make sure, do you have that written down?
No.
All right, make sure you write, let's go back. Make sure we write that down so we know how to say it. Corey?
Y equals the log base 3 of x.
Perfect. Y equals log base 3 of x. So the fact that he tells me base 3, I would do something on the calculator if I was doing this problem out. All right, I would somehow type that in. And we'll learn how to type it in later. All right, so y equals log base 3 of x. All right, now we want to do the actual problem, which is to change it to an exponential expression. So when we're done, we're going to have something that looks like this. We just have to figure out what goes in the 3 boxes. All right, Joe, what's my base there? Corey, can you pronounce that one more time for me?
Y equals the log base 3 of x.
There you go. So he said it when he pronounced it. Log 3, base 3. So 3 is my base. So when we rewrite it, remember the base bottom. The base is always the thing that's going to have an exponent on it. That's what makes it a base. It has to have an exponent. So 3 is going to be my base. What's going to be my exponent?
Would it be y?
Yeah, it's going to be y. Remember when I wrote this? Log equals exponent. The log always equals the exponent. So if I look at my problem, I'm like, okay, the log equals y. So that means when I rewrite it as an exponential, there's my exponent. And
What? What'd you just do?
so logarithm always equals the exponent. So your log always equals the exponent. So if you have a log and it's equal to something, whatever it's equal to is the exponent. That's why y is an exponent right here on the other side. Logarithms always equal exponents. So this is just a way of changing one thing to another thing. We're not really doing any math at all. We're just, bless you. It's kind of like we're translating it into a different language. This is log language. We're translating it to exponential language. We use both languages. It depends on the problem. This isn't asking us to solve anything. It's just practice changing one to the other. Eventually, we're going to solve. And part of solving is changing it from one thing to the other. So that's why we're practicing it. So what's this thing called? It's the argument. And what happens if you argue with people?
You're alone.
You annoy them. You end up alone on the other side. That's why the argument is alone all by itself on the other side. Now, if you put it like this is the same thing. 3 to the y equals x, x equals 3 to the y. That doesn't matter. You just want to make sure 3 is the base, y is the exponent, x is alone. All right, let's try this one. All right, let's just start off by reading what that one says. Justin, how would you read that one?
Y equals log 5x.
What you said would be this. That's y equals log 5x. Yep.
Y equals log base 5 of x.
Perfect. Y equals log base 5 of x. Yep. So now we're going to rewrite it. The reason I have you pronounce it is because if you pronounce it correctly, you already know what your base is right off the bat. What's your base? It's going to be 5. Yep. So that's going to be my base. And what makes it a base is it's going to have an exponent on it. So now we have to decide what the exponent is. And there's a phrase I keep saying to remember that. Logarithms equal exponents. So look at your log, look at what it's equal to. There's your exponent.
Is it 5 to the y?
Yep, 5 to the y.
That equals x.
And that's going to equal, again, that's called the argument. If you argue, you end up all alone because you annoy people. And that's it. There's nothing you can do to solve that. If you were going to solve that, I'd have to tell you something else. Like maybe I would have said y is 2. And then when you rewrite it, you'd have 5 to the second power. And you could do out 5 to the second power, which is 25. But there's no other numbers, so you can't solve it. Okay, any question on that? So it's just changing something from log format to exponential format. But both of these mean exactly the same thing, just different ways of saying it. Okay, now let's try it the other way. Now we're going to start with something that's an exponential. And we're going to rewrite it as a log. So if you're going to write something as a log, what do you think the very first thing you need to write down is, no matter what numbers and letters are in the problem?
Log.
You got to put the word log. Yeah. So I already put log equals, and now we'll fill out the rest. So there's three things. This, and this. Let's start with the one on the left. Logarithms always equal what kind of number? Logarithms always equal exponents. So look up above, find your exponent. 3. So 3 equals log, what do you call this thing down here?
Base.
Base. So look at up above, look at where the base is.
1.2.
1.2. We know it's the base because it has a number that's higher. Anything that's higher is the exponent. Anything that's lower, that's your base. I just need one more space. And the last thing is what you're taking the log of. And what do we call that thing?
Or the argument.
It's the argument. An argument always ends up alone. So look up above. What's all by itself? M. And that's how we change something from exponential into log form. Generally, when you have a problem, you just change it. If it's already in log form, you're going to change it to exponential. If it's already in exponential, you change to log. Just change between the two. All right, let's try this one. Same directions, change to log form. Ephraim, what's the first thing I always write down when I'm doing a log problem? Doesn't matter what numbers or letters are in the problem.
Equals log.
Yeah, just put down your equals, put down your log sign, and now fill in the three things. Dylan, logarithm always equals what kind of number?
Exponent.
Exponent. What's my exponent here?
B.
Yep. So logarithm equals exponent. Derek, the number that's a little lower on the log, we call
Base.
the base. And if we look back up top, what was the base in our original?
E.
E. And the last thing we want to fill in on the log is the argument. You know where to look for that, because when you argue with someone, you end up alone. So that's always all by itself on the other side. There's your argument. That's how you do it. Any questions on that one? All right, we'll try, let's try one more. So this one is a to the 4th equals 24. Right, so Savannah, what's the first thing I would put down if I'm going to write this in log form?
Equals log.
Yep. If you're going to write it in log form, you got to put the word log. Joe, without me kind of saying everything again, can you tell me what goes on the left?
4.
Yep, logarithm always equals the exponent. How about the next thing that's a little bit lower? Christian?
It's the base. It's maybe A.
It's the base, and I look up above. Oh yeah, 4 is the exponent. The thing that's lower must be the base. So that's my base. And the last thing I need is my argument. Yep.
24.
And that's always all by itself. Again, if this was lined paper, there's your line right there. That 24 is not an exponent. It's right on the line. The A is actually under it. Now you got an exponent, 24 cubed. So get rid of that. All right, so going back the other way. Just make sure we still remember that one. So now we're going to change it back to exponential. And I'm going to show you something that you might not know about this one when we're done. So exponential, the word log is gone. So we can forget about that. Start with my base. Chiara, what's my base going to be? The E. It's the number that's lower than everything else. E. All right. Corey, logarithm always equals what kind of number?
exponent.
There we go. So that's my exponent. And now I need the thing that ends up all by itself. It's the argument. And in this case, what's your argument?
B.
B. And that's all you have to do. But what I want to show you about this one is something about this, E. E, it's not just a random letter. There actually is an E built into most, well actually probably all scientific calculators. And E is the number 2.718, roughly. So E is actually a number, just like this. Anybody that looks at this one, most people are more familiar with that. They know that that's not just a random letter. It stands for something. It stands for 3.14. Well, E isn't just a random letter. It also stands for something. We don't use E as much, so people aren't as familiar with it. But where you use it is when you do logs. So this is actually a problem. If I wanted the answer, I could do E to the negative third power and get the answer, 0.05. Okay? So the answer for B in this case is 0.05. They didn't ask us to do that, so I'm not going to write it down. Okay, but I just wanted to show you E's something special. Okay, and why is it 2.718? That gets into a little deeper about logarithms and E, and you can actually look at a graph and stuff, but all you have to know is E is 2.718. It also doesn't keep repeating. It almost looks like it does, like 1828, 1828, but it doesn't keep going 1828, 1828. I think the next number is something different. I don't remember what it is, but it doesn't repeat. All right, so here's one that says solve, right? Or find the exact value. That means when I'm done, I want to get something like this. X equals, and I want the answer. So Chris, what out of the two kinds of equations we've studied so far, exponential equations and log equations, which type is that one?
Wait, hold up. I was writing that down. I didn't listen to what you said.
So out of the two kinds of equations we've studied so far, which one is this one?
Shut up. It is exponential.
Uh,
Hold up. Nah, let me look at this. Nah. Hold up.
so to be exponential, it would have to have an exponent in it. There's no exponents in this one. But what is?
It's log. It says log rating. Bro, don't be putting stuff on me.
Yeah, it is log. Because whenever you see the word log, that means it's a log equation. So what did we practice doing so far? We can change something from log to exponential. So let's change it and then just see what happens. And hopefully once we change it, we can just figure out the answer. Because that's all we know how to do, just change it. All right. Can anyone tell me the whole thing? If you change that to exponential, what you would have, Christian?
It's log. 2 to the x power equals 16.
Yeah. Now, this is kind of like one of the problems I gave you at the beginning of class. It's one that's easy to do in your head because 16 is a power of 2. If this 16 was a 15, we'd have a problem right now. Okay, we wouldn't know how to solve it yet. But this we should be able to do. So 2 to what power is 16? Yep, 4. Now, sometimes people look at it too quick and they say 8. If somebody said 8, what's the mistake they made? They were thinking multiplication, like 2 times 8 is 16. This is 2 to what power is 16. So just be careful with that. All right, so x is 4. And let's try this one. Let's change it to exponential and see if we can get the answer. Oscar, could you change that one to exponential for me?
Yeah. X equals.
Yep. Well, actually, no. I'm sorry. I lied. I was optimistic, but no, it's not x equals.
No.
No. It's actually x equals right now. When we rewrite it, the x won't be by itself anymore. Not sure? Yeah, Michael?
25 equals 5x.
Can you say that one more time? 5.
5x over x.
We don't want to put 5x.
Over x.
We don't want to put over x.
Call.
Yeah, 5 raised to the x. So you can say 5 to the power of x, 5 raised to the x, 5 with x as an exponent, but just make sure you say 5 is the x is the exponent. And then what goes on the other side?
Equals 25.
Yep. There we go. So 5 to the x equals 25. Again, another one that we can do in our head. What's x here? 2. Now, it's not always going to be a nice number, and we'll learn how to use the calculator when that happens. Any questions on that? It's a very simple log equations to solve. Let's try this one. Let's change it to exponential first, and then we'll try to figure out what's going on. So Joe, can you change that one to exponential for me?
3 to the x power equals 1 over 20.
Yes. Now, if you're stuck with that, you're thinking, wait, 3 to a power has to give me a fraction. Well, start with this one. This isn't the same answer, but it's very close. 3 to what power would give you 27? 3. 3 to the third power means 3 times 3 times 3, which is 27. So the answer to that problem is 3. The answer to this problem is not 3. It's negative 3. So anytime you want to have a fraction, if you've got an exponential expression equal to a fraction, that means this has to be a negative. That's how you get fractions. A negative causes it to flip. So if 3 would give you 27, negative 3 would give you 1 over 27. And that's pretty easy to check because you can just type it in if you want to check it. Type in negative 3. Do it out. 3 to the negative third. 3 to the negative third, I get that number, 0.037. Well, let's see what 1 divided by 27 is. Yep, comes out the same on each side, so I know it's right. Any question on that one? All right. I already kind of mentioned this a little bit, but E, again, is actually a special number. Does anyone remember what it is? 2.718. Yep. That 1828 doesn't keep repeating again, it changes. All right, so now when we see E, we know that it's not just a random letter. So when you're doing log problems, you would never want to pick E to be a variable. Like if you had a word problem and it said like, I don't know, how many elephants are there? And you were estimating elephants. Although elephants begins with E, E would be a bad choice for a variable. Pick a different letter. A for animals or something. So we had this earlier on, log, and the base was E. I forget which problem it was. But yeah, we had it right here. Example 3, log base E. You would never actually see that. No problem would ever really be written log base E. The reason is because log base E is used a lot. So what they do is they give log base E a special abbreviation. So I asked you guys earlier, does anybody know what this ln button is? Well, that's what I'm going to talk about right now, that ln button. Anytime you see log with a base of E, in place of that, you're going to see a lowercase l, lowercase m. That lowercase l, lowercase n is an abbreviation for log base E. I mean, it doesn't shorten it that much. I mean, log base E, you got to write 4 letters. ln, you're writing 2. But it shortens it a little bit. Right? So log base E is exactly the same thing as writing ln. And the x is just whatever your argument is. X is called the argument here. It's also called the argument here. It's the same thing. And I can type in ln on the calculator by doing something like this. The ln of 8. 8 is called the argument. It's not doing ln times 8. Right? If you think of that as ln times 8, it's like saying this. What's square root times 4? Well, I can take the square root of 4. I can do this. But how can I just take some random symbol times a number? That doesn't really make sense. Okay? You have to put something in the symbol. That's the way square root works. Same thing with ln. You have to put something in the ln to make it work. I just put in e. You can put in almost any number you want except negatives and 0. You can never use zeros and negatives with logs. If you try, look what it says. It says non-real answer. So technically that means you could do it, but what kind of answer would you get?
Imaginary.
It would be imaginary. So we're not dealing with imaginaries. So can't do negatives, and you can't do 0. But notice, when I took the log of 0, is that the same error? No. So I can't do the log of 0 either. But that's a different reason. All right? So you just have to kind of remember in your head, you cannot take the log of zeros or negatives.
Why can't you take the log of 0?
Well, think about if you had something like this. The log of 0. And you change that to exponential. All right? Watch what happens. 5 is the base. X is the exponent. Equals 0. What power could you raise 5 to? Nothing. It's impossible. No matter if you take 5 and you raise it to any number that you want, positives, negatives, fractions, you can't raise 5 to a power and ever get 0. Can't do it. You think, well, what about 5? What about to the 0? 5 to the 0. 5 to the 0 is 1. If you do negative numbers, like if you did negative 2, all that's going to give you is this. 5 to the negative 2 is 1 over 25. So I mean, there's no way to get 0. So that's fine. So you might, or you might not, be wondering, why did they use lowercase l, lowercase n? Because when you have log base e, they call that the natural log. Natural log. So why did they use NL? Natural log, like the order you pronounce it? I don't know. But that's what LN stands for. Natural logarithm. There's only 2 logs that have a special name. This is one of them. If the base is e, it's called a natural log. What's a little tricky about this abbreviation is the base is hidden. You have to remember it's still there. Okay? ln is always a base of e. Just like if I write x, there's a number in front, but it's hidden. We don't put it. What's the number that's in front of x?
1.
Right. It's hidden. All right, so just remember, ln hides a base of e. All right, so that's one log that has a special name. I'll tell you the second log that has a special name after we do a couple examples. Okay, so let's change this to an exponential expression. So we've already done this. Now, look at ln x. First thing you need to know to write it as an exponential is what's your base. There's no base there visible. It's invisible. What's my base? Yep. E. E is my base. Remember, E, it's invisible. It's just not there. If it helps you, you can rewrite the ln like this. Write it out the long way, and then you can make it visible. So E is my base. What's my exponent? 8. Logarithms equal exponents. Even natural logarithms. All logarithms equal exponents. And what gets by ends up alone?
X.
x, which is the
Argument.
it's the argument. And that's something you could do on the calculator. Just take e to the 8th power and you could find out what it is. But we're not going to do it. Let's see. 6 and 7 are exactly the same problem. ln x equals 8, ln x equals 12. It's just a different number. So we'll skip that one. All right. So I told you there's 2 logs that have special names. Base e is your natural log. Good. Base e is your natural log. Base 10 is called a common log.
Are you sleeping?
There's no other special bases besides that. Base 10 is called a common log. Base e is a natural log. It's the only special names we ever use. And that's how you would write it. Log base 10 of 5. I'm guessing everybody could have pronounced that. Maybe you knew it was called a common log, maybe you didn't. Well, now you know. Now, that's also a common log. Log 40. What's missing? When I pronounced that, all I said was log 40. There's no base, and that's fine. This is the only time you're allowed to leave the base blank. If the base is not written. Just like in math, there's a lot of things, if you don't write them, there's something there. Everybody assumes what it is, and we all agree what it is. If you write a variable without a number, assume it's a 1. If you write a log without a base, we assume it's a 10. So most of the time, when you see me write down a common log, I'm not going to write it with the base of 10. I'm just going to put log 40. And that's exactly how the calculator does it. If I type log 40, notice there's no base. That means the calculator is assuming I want base 10. So if I press this button at the top, I get base 10. If I press this button at the bottom, I get base e. Those are the only 2 log buttons on this calculator. That's it. So what problem does that kind of leave us with? The top button does base 10. The bottom button does base e.
What about the other bases?
What about all the other bases? What if I wanted to do a log and the base was 3? What if the base was 5? Well, they can't put a button for every single base because there's infinitely many. So somehow we've got to use the buttons we have. And we'll learn how to do that at some point. But there is a way to do other bases besides 10 and e. But 10 and e are the ones the calculator has a built-in button for. All right, so let's try to solve this problem. Now, it looks a little more complicated, but I want you to think of it in 3 sections. Here's 1, it's your base. All that stuff right there is your argument. 4x minus 7, there's one big argument. And 2 is what the logarithm always equals. We've talked about that. So when we rewrite it, we should know what that 2 is going to be. All right, so Chris, we've got an equation. We've studied 2 forms. Which format is that equation? Log form, yep. So we've got a log equation. Start with the 3. Dylan, what's the 3? That's the base. So when we rewrite this as an exponential, 3 is my base. How about my exponent? Yep, 2. Logarithms equal exponents. 2. And now the last thing is what goes all by itself on the other side. It's the argument, the 4x minus 7. So from here, it's just an algebra 1 equation now, solved. Okay, we've done the log part. We got rid of it. Now we finish solving it. What's the first thing I would do there to solve that?
The exponent.
Yeah, let's do the exponent and 3 to the second power.
9.
9. Now we got 2 steps left.
Add 7 to both sides.
Add 7. It's gone. 9 and 7 gives me,
16.
so I get 16 equals 4x. And now my last step.
Divide by 4.
Divide by 4. And 16 divided by 4? 4. And that's it. So a lot of times when you're solving a problem like this, one of the steps is kind of what I taught you, and the rest of it is just algebra. That's a pretty simple algebra one. Sometimes the algebra does get more complicated. Like there will be a quadratic equation at some point today, not today, at some point this week though. So factoring is going to come into this at some point.
Yeah,
All right, let's look at this one, a little different. Look at where the variable is. Where's the variable? It's the base. Look at this one. The variable was in the argument. So when the variable's in a different spot, something different is going to happen when you solve it. You're still going to go through the same first step, though. What's my first step with that equation?
Change it to exponential.
Yep. And Skylar, can you tell me what that would be in exponential? X squared equals 64. All right. Now that one's a little different. How do I solve that one? Yep.
I don't know how to solve it, but I can tell you it's 8.
It's 8? All right, I agree. The answer is 8.
You could take the square root of 64.
Okay. So I take the square root on both sides.
To get x alone.
Yep, to get x alone. And now, what times what is 64? 8. What else? What other two numbers can you multiply together that are the same and get 64? Negative 8. So x could be 8 or negative 8. But before I write it down, what did I say about logs? They have to be what kind of numbers?
Positive.
Positives, right? You can't do 0. I explained that to Joe. And you can't do negatives because that would come out imaginary. So don't write the negative answer. Technically, there is another answer, but it's imaginary. And we're not doing that. All right, so we looked at one where the variable was in the base. We did one where the variable was in the argument. That was this one. And now let's look at this one. What's different about this one? This one's totally different from A and B. Yeah. It's already in exponential. So what do you think we're going to do with it?
Change it to log.
Let's change it to log. This one we're going to try changing the other way and see if we can solve it. So we're going to have a log. What's my base? E. We're going to come back to that. We talked about this earlier. But that's fine to start. Log base E.
Wait, why are we going to turn it to log?
Because we have a problem that is already in exponential, so we can't do what we did on the last two. And the only thing we've learned is to change from one to the other. So we're just going to try changing it to log form. Logarithm always equals what kind of number? Exponent. I'm missing one thing I haven't used yet. The 5, and that's all by itself, so it's going to be, it's the argument. Now, what did we say earlier about this part that I just put a box around? ln, so we're going to use that abbreviation. Now remember, that's not ln times 5. The 5 is plugged into the ln. So we're just going to leave it like that. It's the natural log of 5. But right now, that's equal to double x. How would I just get x by itself?
Divide by 2.
Yep, divide by 2, divide by 2, and there's your answer. If they wanted to know what this problem is as a decimal, you would do You type it in just like this. ln of 5 divided by 2. And the correct answer as a decimal is about 0.805. Now, how come I get a different answer? I typed in almost the same thing. What happened? Yep. Right. This one right here is basically doing this. It's doing the ln of 2.5. That's not what you want. You want the ln of 5, get that answer, and then take half of it. So the rule here is what's important if you type it in on a calculator. What do you have to be careful with? You got to be careful with parentheses, okay? You want to make sure this is the correct way. That's the wrong way. Any questions on that? Okay, so that's the first part on logs. So the homework tonight is all evens, everything. And it's 10 to 16, 22 to 28, 34 to 38, and 92 to 98. So tomorrow we'll do the second part on logs, which gives us a few more formulas, a few more things we can do. And then 7.4, it's actually kind of good that we're doing that one because it's like a review. 7.4 takes everything we learned during the week and it just solves equations. So 7.4, there's nothing new. Just all solving equations.